Good morning, guys. Today we're going to be doing angles of elevation and angles of depression. I'm going to start with angle of elevation. Remember, guys, to elevate means going up. Basically, it's when you look up. Depression is when you look down. An angle of elevation, the angle of elevation of an object as seen by an observer is the upward angle between the horizontal and the line from the object to the observer's eye. So basically from your horizontal position, when you face up, you create an angle of elevation. So basically the observer from the horizontal point, when they look at the object, which is a globe, they create an angle of elevation, and the line between the observer and the object is simply a side line. Okay, the angle in between the horizontal plane and the object, the side of the object, is simply what we refer to as the angle of elevation. This will also be an angle of elevation from a horizontal position, that is you. When you look at the object up there, it creates an angle of elevation. Angle of depression is the downward angle from the horizontal to a line of sight from the observer to some point of interest. Basically, if I'm an observer from the horizontal line, when I face down to that object, I'll create an angle of elevation. Beta degrees will simply be my angle of depression. Depression. B degrees will simply be my angle of depression. Okay, so from the horizontal point, when you face down, you create an angle of depression. So theta in this case will be an angle of depression. Now take a second, look at this. What angle will theta be? Will it be an angle of elevation or will it be an angle of depression? It will be an angle of elevation. Alright? Now, this one depends on who the observer is. The girl that is right on the ground, when they face up and looks at the object, which is the boy, she will create an angle of elevation. But the boy, on the other hand, will create an angle of depression when they look at the object, which is the girl. Okay. Now, in this case, obviously, angle of elevation, and from the boy's point, it will be an angle of depression. Now I will be doing the first activity, exercise 9 on page 29 of our textbooks. It says that we need to calculate the height of the building if the angle of depression from the top of the building to the car parked on the same horizontal level as the base of the building is 24 degrees. The car is parked 45 meters away from the base of the building. So basically AB will height of the building, and when you look at the bottom of the building and the car, they are parked on the same horizontal plane, and the distance between the two will just be 45. When they say they're on the same horizontal plane, it means that they're on the same plane, not on different planes. We have a horizontal plane, we have a vertical plane. In this case, they are just on the ground. Both of them are on the ground, and the distance between them will be 45 meters. We want the height of the building, but we were told that the angle of depression from the top of the building is simply 24. Okay, so what you're going to do is draw a line that is horizontal to the object. Our object in this case is a line horizontal to the object. When I face down from the object to from the observer, as a matter of fact, to the object, my object is C, which is the car. When I face down and I look at C from my horizontal position, I will create an angle of depression. And please note that the angle of depression will be parallel to the plane where the object is in. So basically, that line that I've showed you from A, the horizontal line from A, will be parallel to BC, which is the horizontal plane where the car is positioned. Now, because those are parallel, it means that angle C will simply be 24 degrees as well. And the reason why angle C is 24 degrees because those will be your alternate angles. I will repeat this. parallel line from A. When you look down, it will create an angle of depression which is 24, and hence C is equals to 24. That is because the line that is horizontal to A will be parallel to a line that is horizontal to the object, which is BC. They will create an angle of alternate angles as a matter of fact, meaning that C is simply 24 degrees as well. Now, all you want is to have an angle in a triangle so that you can be able to calculate the side that you are required to calculate. In this case, you're required to calculate the height, and you need to find a relationship between the height, which is AP, and any given side as well as the given angle. You have one angle that is given, which is 24 degrees, which is calculated as a matter of fact in that triangle, and we're looking at triangle ABC. We have 24 degrees. We also have BC, which is 45 meters. We need to find H, which is the height. What is the relationship between the height and 45 meters, which is BC, which is adjacent side to 24? Which ratio can combine the height and 45, which is your adjacent? It is 10. So 10 of 24 will be equal to your height, which is height, H divided by 45 meters. So 10 of 24 degrees will be equal to height divided by 45 meters. Multiply both sides by 45 meters. You'll have 45 multiplied by 10 of 24 degrees. That will give you 20,04, and that will be the height that you were required to calculate. Next question. It is question 3 on page 21. Question number 3 on page 21. I will show you the diagram as I read the question. It says the angle of depression from a beacon of a cliff to a boat in the sea is 35 degrees. So basically that's what we have a beacon. We have it, it's a straight line, and it's obviously on the cliff, and we have a boat in the sea. So basically, remember, the beacon will simply be it will be perpendicular to the ground. In this case, it's your horizontal plane, and the ground obviously represents the sea in this case. And obviously, the beacon is on top of the cliff, right? We already know that the angle of depression will be 37, and the distance between, we are told that the boat is 125 meters away from the base of the cliff. So basically, this height represents the cliff, and obviously the boat is 125 meters away from the base of the cliff. Now, when we look at the beacon and the boat, we don't know what the distance is, but we know the angle of depression, meaning that the angle inside that triangle will also be 37 because of alternate angles. You realize that the horizontal line from the observer is actually parallel to the horizontal line of the object, and hence resulting in the angle that I've just shown you there being equal to 37, because those will be alternate angles. We need the distance between the beacon and the boat. All right, that's why I've put it as a question mark. But we only have one angle in this triangle, and we also have one side, and the side that is given in that triangle is the adjacent side, and the angle is 37. The only thing that can combine the hypotenuse, which is the distance that we need to calculate, that is the distance between the observer and the object, we need to find the ratio that will combine the hypotenuse as well as the adjacent. So that ratio will simply be cos. Hence, here we're going to say cos of 37 is equal to adjacent all over hypotenuse. We do have the adjacent. Manipulate the formula, and your hypotenuse will be 125 divided by cos of 37, and that will result in your hypotenuse being 156,52 meters. Let's do number 5. It's actually number 4. A man sits on the roof of a block of flats 25 meters away, 25 meters above the ground. He waves at a friend on the ground. So basically, the height right at the top of this horizontal of your vertical line, we have a man that actually is on top of flats and waves at a friend who's right at the bottom, and they are 25 meters away. He waves at a friend who is 25 meters away from the ground. The ground means that where the flat meets with the ground. So basically, from that point up to a friend, the distance will simply be, oh, the distance from the observed guy on top of the building or the flat and the friend is 45 meters, and the distance from the roof to the ground floor is 25 meters because the man is right on top, all right? And this is what we have. We know that A represents the man and B is the ground floor of the flat and C represents the friend. And the man A is actually 45 meters away from the friend who's on the ground, and the height of the flight is 25 meters. The question is simply asking us to calculate the angle of depression from the man, so we are required to calculate theta. You need to find a ratio that will combine the three things that you're given here, which is the hypotenuse, opposite, and theta. Which ratio will combine those? Opposite to theta, we have 25 meters. Hypotenuse, we have 45. So we have opposite and hypotenuse, all right? The only ratio that will combine your opposite and hypotenuse will be the sine. So sine of theta will simply be opposite over hypotenuse, which is simply 25 over 45, and all you have to do is just to solve for theta by finding arcsine of 25 over 45, and theta will be 33.75. That's all you were required to calculate. So our angle of depression here will be 33.75.